All right. Okay. We don't have a while you wait today because we're starting a brand new section. Okay, but we're going to start by looking at analytical geometry. Now, luckily for you guys, because as a maths teacher, I hear this all the time, like, "Oh, man, when am I ever gonna use algebra? Another day I went to the mall and I never used algebra." Okay, today we're actually going to learn about something that is really, really used in things that we work with on a daily basis, like your Google Maps, like the GPS tracker in your car. All of these things work around analytical geometry. And analytical geometry is actually called coordinate geometry. And oh my goodness, guys, can we welcome Andiswa? Hello, Andiswa. Welcome to MathsLive. It's so lovely to meet you. Hello, Andiswa. Lovely, lovely to have you with us for the first time today. I hope you're going to enjoy today's lesson. Okay, that means today ma'am has to behave because she's got new people in the class. So I've got to behave properly because all the others already know I'm a little crazy. But I will behave, I promise. It's lovely to have you with us, Andiswa. Thank you so much for joining us. Okay, so analytical geometry stems from the idea of coordinate geometry. And because the Earth is mapped out as a coordinate already, all the satellites that are currently orbiting the Earth, the satellites that are orbiting the Earth are actually using a geolocation, which is something that is brought about by coordinate geometry. A lot of coordinate geometry can also be found at NASA or at SpaceX. So if you ever thought to yourself, you want to go work for Elon Musk, maybe, you never know, then a lot of what they work with is things like coordinate geometry or analytical geometry. This is the foundation of all the stuff that they use over there. All right. From a smooth criminal. uh, Michael, I'm gonna have to screenshot that and share that with the other teachers because that's just so epic. All right. Let me just double check with everybody. Thumbs up. Are we all ready to get into today's lesson? We're actually going to be talking about just the distance formula, but we're going to talk about it in a lot of detail. I don't know, Balisa. I think it's still afternoon, but we're hinging on evening. So it's one of the two. Okay. All right. Great stuff. Let's get started on what the distance formula is. Now, I've given you a formula for the distance formula. Just out of curiosity, does anybody feel like this looks familiar? Have we learned any other formula that kind of sort of looks like the square root of something squared plus something squared? Where have we seen this? Who knows? And don't just say analytical geometry, ma'am. What other formula do we know that kind of looks like something squared plus something squared equals something else squared? Well, sure, the gradient, but also, yes, Cat, that's the guy I'm looking for. That's it, Pythag. It almost looks like Pythag with a bit of a twist, right? Because normally Pythag would read something like x squared plus y squared is equal to maybe d squared or r squared, depending on whether we're doing trigonometry or not. So something along these lines, right? This kind of stems from the idea of Pythag. So this is the distance formula as we look at it. And I'm going to try and explain to you guys where it actually comes from by using an example. Okay, so we've been given the example here. Calculate the distance between point A and point B. Now, I've got a Cartesian plane over here, which is so lovely and drawn out. That's my Y. That's my X. This is negative Y. And this is negative X on this side. All right, so if I had to plot these 2 points, I know that negative 2, I'm just going to go negative 1, negative 2, negative 4. So I'm going to 1, 2, 3, 4. Down here somewhere, that's where the point negative 2, negative 4 would be. Negative 2, negative 4. This is point A. Right, now if I have point B, which is all the way on the other side, 1, 2, 3. That's 3 over there. And then I'm just going to pretend 8 is over here because I didn't make enough space for 8. I'm going to pretend that that's 8. All right, this is point B. 3 and 8. Okay, so I know that I want the distance between these two things. So I want the distance from point A all the way to point B. But if I had to think about how to get from point A to point B, I know that, let's say, for instance, we actually had roads like on a map, right? If I had roads like on a map like this, I wouldn't be able to get from point A to point B. That's not going to work, right? I would have to take roads. I would have to go left on Sigasa Street, and then I would turn right onto this street until I get to my destination. So when we think about the idea of the distance formula coming from Pythag, what we're basically saying is, what if we moved in this direction, in the x direction, from there to there, and then we moved from there in this direction. Okay, so we would go right, and then we would move upwards like that, right? And if you can see what's happened here, ma'am has made a perfect 90-degree angle for us to figure out how to get there, right? Now, if we had to figure out the coordinates of this point right here, what would the x coordinate over here be? What would the x coordinate over here be, guys? Can we see it? Where does this line cut the x-axis? The x coordinate would be 3. Are we all in agreement? Yes, because it cuts the x coordinate there, and my y coordinate over here would be -4. Just give me a thumbs up if everybody understands where ma'am got this point. Are we all okay with where ma'am got this? Yeah? Okay. So I've just moved this along this side so that it's right underneath that, and that one goes there. So now when we look at, we want the distance from there to there. That's my x direction. I'm moving in my x direction, right? Now, if I want the distance from here, from -2 to 3, how many units do we have between -2 and 3? How many units would we have in this direction? Okay, so to get from -2 to 0, that would be 2 units. And then from 0 to 3, that would give me 5 units. So from -2 all the way to 3 is going to be 5 units. And then if I want to get all the way from this point, from this -4 all the way to 8, how many units do I see from there to there? I know from -4 to there, that's 4 units. And then from 0 to 8, that's another 8 units. How many units do I have all together on this side? Anybody got an answer for me? 12, correct. There are 12 units. Right, there's 12 units here. Now I'm wondering if I'm lagging because I'm getting answers way after the fact. Right, it's 12 units. So if I wanted to calculate this using Pythag, I would then take 5 units squared plus 12 units squared, and that would give me AB squared, right? But now, because it's going to take me forever to do that, all I'm going to do is I'm going to find the difference between those 2 points squared plus the distance between those 2 points squared. And that's where the distance formula comes in. So I'm going to say the distance for A is AB, or the distance for AB would be the square root of the difference between my two x coordinates. So 3 minus -2, 3 minus -2, all squared, plus 8 minus -4. Right, which would give me the distance between the two of them. So that's going to give me the square root of 3, a minus and a minus will give me a plus. So 3 plus 2 will give me 5 squared, just like ma'am said, this would be 5 units, plus 8 plus 4 would give us 12 squared. And that would give me the square root of 5 squared plus 12 squared, which is 169. Does anybody have an answer for me? The square root of 169, AB is equal to how many units? 13. Thank you, Gerardillo. Beautiful. 13 units. Okay, so basically what all we're doing really is we're finding the difference between the x values and the difference between the y values, and we're using Pythagoras together with that to get to the answer. Thumbs up. Is everybody okay with how ma'am has gotten there? We don't have to actually do all of these steps. You don't have to do the 5 units and the 12 units. We just need to do, we're going to do it in a particular order, and I will show you how we're going to do it. All right. So what we're going to do here is we're going to do this. We're going to name this first coordinate down here. We're going to label it point x1, coordinate x1 and y1. And then up here, we're going to name this x2 and y2. Now, if we look at the formula for the distance, we're going to get the square root of x2 minus x1 all squared plus y2 minus y1 all squared, which is exactly what ma'am has done there. Okay, I haven't changed a single thing. All right, can we look at another example? Let's look at a different example. We're going to do these two. We're going to do number 9. I skipped the first part because that was pretty easy. It says, find the distance between each pair of points. So first thing we're going to do is we're going to take the first coordinates of A and we're going to name them x1 and y1. And we're going to name the coordinates of B, x2 and y2. And then we're just going to use the formula. AB is equal to the square root of, now I know we're going to get x2 minus x1 all squared plus y2 minus y1 all squared. Let's punch that in. I'm going to get AB is equal to the square root of, open brackets, x2 is 6 minus 0 all squared, x2 minus x1 plus 8 minus 0 all squared. And that will then give me, you can punch that into your calculator exactly the way that we're looking at it, and it should give us an answer. Okay, the square root of 6 squared plus 8 squared should give us exactly 10 units. Okay. Are we all okay with how to calculate for this? All right, I'm going to give you guys a chance to do 10, 11, 12, 13, and 14. In fact, I think we should skip 13. 13 is kind of simple. We're not going to do that. Okay, 14. Now, I want you guys, if need be, I want you guys to leave your answer in surd form. Do we understand what surd form means? Are we okay with what surd form means? Okay, Oko gives me the thumbs up. I'm gonna assume, okay, Michael says no. All right, so here's what happens on your calculator, Michael. Normally your calculator, if you're using things like square roots, it will normally give you an answer maybe like 2 root 10. Okay, this is the surd form. Okay, this is surd form. I know that we're used to doing things like clicking SD and then it'll give you a number like 6 comma something, something, something. Don't click SD. Give it to me with the square root in the answer. Okay, that's what ma'am is implying. We cool with that? All right. And as always, guys, pop your favorite emoji in the chat when you're ready. Okay, we're not going to take too long with this particular question because I want us to try something a little bit more challenging because this is just plug and play. We are just using the formula, plugging the things in and finding it. So, all right. Hi, Andy. So you
Hi,
can
Auntie.
unmute my.
So you can unmute my.
Oh,
Hello, ma'am.
hello, my darling. What's up?
Ma'am, I wanted to do the first one if everybody's ready.
Oh, yes, absolutely. Okay, keep your hand up. Um, just do me a favor and pop your favorite emoji in the chat once you've done all four, and then we'll have a quick chat. And then once everybody's caught up, you can do the first one.
No
Okay,
problem.
lovely. Don't put your hand down. Don't put your hand down. I'm gonna give everybody two more minutes, and then we're gonna get started. All right, peeps, that's all the time ma'am's gonna afford you. I've already got a volunteer. I'm loving this. Love, love, love it. Okay, so we're gonna start with number 10. And Andiswa has so graciously agreed to do number 10 for us. Are you ready, my darling?
Yes, ma'am.
Okay, what's our first step?
So the first step is I wrote AB. I wrote the
Okay,
coordinates of A and the coordinates of B. And then
good.
in the script, I substituted 6 minus 0, close bracket, to the power of 2.
Okay, cool. 6 minus 0, all squared.
And then plus, and then I opened a bracket and then I said 8 minus 0, close bracket, squared.
Good. Okay, and lovely for us. They don't care if we use our calculators or not on analytical. So what answer do we get here?
And then I got 6 squared plus 8 squared.
6 squared plus 8 squared.
And that gives 6 squared is equal to 36 plus 8
Mhm.
squared is equal to 64.
All good.
And then if you add that together, it gives us the square root of 100.
Which is equal to
Ma'am, were we supposed to not
Mhm.
leave it in form?
Only, well, yes, in third form, but only if the answer comes in third form. Okay, so if we have no choice. But we do know what the square root of
Oh,
100 is. It's the perfect square, right? So the answer is
yeah,
just
10.
10. That's it. That's all we needed, 10 units. Okay, this is actually
Yes,
number
ma'am.
9. Okay, lovely. Thank you so much, Andy. So would you like to do 10? Can we try? Do you want to
No,
try 10 with
thank
me?
you. I'm scared. What if I got it wrong?
Okay, it's okay. I'll walk you through it. Don't even worry. Okay. So first thing that ma'am's gonna do is I'm gonna label these. Okay, I'm just gonna label x1, y1, and over here x2 and y2. All right. And I know this one is called RS, not AB. So I'm going to say RS is equal to the square root of, and now all we're going to do is we're going to follow these steps here. Do you see the steps that ma'am is highlighting in green? Yes?
Yes, ma'am.
Cool. So I'm going to start by opening brackets, and then I want you to give me the value for x2 minus x1. What is the value of x2?
15.
Oh,
Sorry. 3.
good. So I'm going to get 3 minus what? Minus?
X1, which is -2.
Good. So I'm going to have 3 minus -2 all squared plus, right? What comes next? And then I open brackets and then
Y2, which is
which was
15,
good, 15.
minus Y1, which is 3.
Excellent. There we go. Beautiful. That's all ma'am needed. Okay, because we're just
Yes.
plugging in the numbers. So that's going to give us the square root of, let's talk about what's happening inside this bracket. 3 minus -2 would give us,
Sorry,
what would happen to these two negatives? 3 minus -2 would give us?
5.
Correct. It's positive 2, right? So 3 plus 2 would give us 5 squared plus over here, I'm going to get 15 minus 3, which is just that part over there for me.
Oh.
12 squared. Correct. 15 minus 3 will just give us 12 squared, right? And then we just need to find the answer from here. Okay, 5 squared would give me 25 plus 12 squared is 144. And that is the same as, let me put it over here. 25 plus 144?
106, 169.
169, good. And then the square root of 169 will just give us
13.
13 units. There we go. Beautifully done, my darling. Just, wow, excellent work. Nicely done.
Thank you,
See,
ma'am.
it was not that bad. Well done, Andiswa. Very
Yes.
nicely done. Ah, very proud. Excellent. All right, let's look at question 11. Okay, remember, guys, we're just following the steps. I'm going to start labeling. I'm going to make that one x1 and y1, and then make this one x2 and y2. Now, I want you guys to be very careful. You cannot choose that if you make this x1 and then you want to make this y2. Okay, we cannot do that. We're not allowed to do that. If one of them is x1, the corresponding y coordinate must also be y1. Okay, so all of them must coordinate with each other. They must correspond with each other. All right, so over here I've got mn. So I'm going to say mn is equal to the square root of, open brackets, x2, which is 9, minus x1, which is 1, all squared, plus, open brackets, y2, which is 13, minus -2 squared, right? That's going to give me the square root of 8, 9 minus 1 is 8, all squared, plus 13 plus 2 will give me 15, all squared, right? This is the square root of 64 plus 15 all squared should give us 225. And this should give us the square root of 289 which is then just the square root of, is it 13? I'm lying, it's 17. It is 13, 17. I'm definitely lying, 17 units. Okay. All right, let's look at number 12 and number 14. I'm hearing ma'am. What's up?
If we do this as a two-step process, we still get the formula.
Yes, yes. Okay. I don't have a calculator near me right now, but honestly, in mathematics, we wouldn't mind if you went from that step to that one. Okay. Because analytical geometry is just plugging playing. Okay. But the next part that we're about to do, you're not going to be able to use your calculator for that. You're actually going to have to use algebra. Okay. For number 12, we're calculating for EF. And that is going to give me the square root of, I forgot to label. Sorry, guys. Okay, x1, y1, and x2, y2. All right, square root of x2, which is -9 minus -12, all squared, plus, open brackets, 6 minus 2, all squared. Sorry about that, peeps. I just got kicked out. I don't know how. I don't know why my Wi-Fi didn't cut out. I just got kicked out of Zoom. I don't know. Zoom is the enemy of progress. We'll just say that for today. Okay. Okay, let's continue. All right, so I'm just going to get here the square root of -9 plus 12. That's going to give me 3 squared. Plus 6 minus 2 will give me 4 squared. That's the same as the square root of 25, which is equal to 5. All right, 5 units. Okay, and then we'll do number 14 just to finish off strong. Okay, 14 is OP. OP is equal to the square root of, and again, ma'am is forgetting to label, y1, x1, y1, x2, y2. All right, and then we just take x2, which is -8, minus -12, all squared, plus y2, which is 3 minus 0, all squared. This should give us the square root of -8 plus 12 would give me 4 squared, plus 3 minus 0 is 3 squared. Again, that is the square root of 25, which is equal to 5 units. All right. Okay. Are we all okay with how to do this? I'm sorry. I know I just kind of jumped in where I left off. Everybody give me a thumbs up. Are we all right on how to calculate for the distance formula? We all good? Can I challenge us? Let's go to a bit of a challenge. Okay. We're going to go to a bit of a challenge. All right, let's think outside. No, Sia's like, no, ma'am, no. All right, I'm going to do the first one with you, and then we'll do the second one together. All right, so this one over here says, the distance between 2 points, 1, 2, and 16p is 17. So this time they tell us what the distance is. Okay, I'll go back for 2 seconds. Here we are, Michael. 1, 2, 3, 4, 5. Okay. All right. If you didn't take a screenshot, we can come back afterwards. Okay. So basically what they're telling us here, guys, is that the square root of something, 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 something equals 17. So they've already given us the answer in this case. So we're going to work with what they've given us, and we're going to kind of work our way backwards. That's what we're going to do. All right, so I'm going to, as always, I'm going to label. I'm going to call this x1 and y1, and I'm going to name this x2 and y2. All right, and then we're just going to use the distance formula. Let me put the formula here. Distance is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. All right, but this time we've got the answer for D. We've got our distance. So I'm going to go in here and I'm going to substitute. I'm going to go the square root of, then I'm going to open brackets, x2, which is 16, minus x1, which is 1, all squared, plus square root, open brackets, y2 is p, so I'm going to put p minus y1, which is 2, all squared. And this is equal to the answer that I would get. I would get 17. Correct, Michael. We're basically working our way backwards. Now, the question says, find the possible values. Of course, we're going to get more than one value, and ma'am is going to explain why in just a second, of p. Right, so we want p, which is the thing inside the square root, right? So the first thing I'm going to do is I'm going to simplify this part over here. Okay, so I'm going to get the square root of 15 squared plus, I can't separate this. They are unlike terms. So they're still going to stay as p minus 2 all squared is equal to 17. Now, p is underneath a square root. How would I get rid of a square root, guys? How would I get rid of a square root? Like if I say to you guys, I've got, correct, that's it. If I've got x to the power of, or the square root of x is equal to 9, I would square it. I would take the square of that side, right? So I'm going to take the square of this whole side. But what I do on the left-hand side, I'm going to have to do on the right-hand side as well. So I'm going to square that side. So I know that the square and the square root will go away. Now what I've got is 15 squared plus p minus 2 all squared is equal to 17 squared. All right, now let's hash it out. 15 squared is 225 plus, what do we do with this thing? Who's got an idea for me? How do I get p minus 2 all squared out? What would I do? Correct, and this one, yo, beautiful, we're killing it. Because if I say to you guys, I've got x plus 1 all squared, you would tell me, ma'am, this is the same as x plus 1 twice, right? I would write it out twice, and then I would do FOIL. That's exactly what I'm going to do here. I'm going to write it out twice. I'm going to go p minus 2 and p minus 2, and then I'm going to FOIL is equal to 17 squared is 289. All right, let's FOIL this out. I'm going to write it first. I'm going to start with this, and then I'll just add plus 225 afterwards. So I'm going to get p squared minus 2p minus 2p plus 4 plus 225 is equal to 289. Right, but now I've got a quadratic. And if I'm solving for a quadratic, I don't need 289 on this side. I need 0. So I'm going to take this 289 over to the other side. Right, so I'm going to get p squared, and then negative 2p minus 2p will give me negative 4p. Right, and then on this side, I'm going to get plus 4 plus 225 minus 289. Can somebody punch that into a calculator for me and give me an answer? If you just multiplied the square in the bracket, it would be wrong, Andiswa. You can't do this. We cannot do that. All right, we're not allowed to. Mathematically, it's not sound. Okay, so you do need to write out the 2 brackets again. Okay, we can't just distribute. Okay, Wikanya says it's negative 64. I'm going to take your word for it. Minus 64 is equal to 0. What would be my next step from here, guys? Can we check again? 229 minus 289. Oh, don't forget plus 4. 4 plus 225, negative 60. There we go. Yeah, it should be negative 60. Right. What would our next step be from here, guys? How would we solve for P?
We can factorize since it's a
Yes,
quadratic.
absolutely. We can use a quadratic formula, or we can just use a quadratic. We can do that, and we can factorize. It's a trinomial, right? So I'm just going to put P here, and now I need factors of 60 that are going to subtract to give me negative 4. Does anybody have any numbers for me? Factors of 60 that will minus to give us negative 4. Who's got the numbers for me? 10 and 6. Good. So I'm going to get negative 10 plus 6 will give us negative 4. That then means that P is either equal to 10 or P is equal to negative 6. And do you see how our question said, find the possible values of P? And we managed to find possible values for P, either positive 10 or negative 6. All right. Thumbs up, thumbs down. Are we going to be able to follow all of ma'am's steps? Did we follow? We can just like, ma'am, no. All right. Okay, we're going to do the next one. If you know what to do, I would like you guys to go ahead and try and do it. Okay, if you still feel like, nah, ma'am, you need to help me, that's fine. We'll work through it slowly together. Okay. All right, let's look at the information we've been given in this next question. It says, the distance between these 2 points is 15. Do you see how they've given us the distance? Right, they've given us the distance. So first thing I'm going to do is I'm going to label x1, y1, x2, y2. Right, and I know that my formula says that the distance formula is equal to the square root of, yes, Keratilo, do you want to try it on your own before I get into it? I'm just going to put the formula down for you. X2 minus x1 all squared plus y2 minus y1 all squared. And I'm going to leave the other one that I did on the screen so that if you get stuck, you can refer back to it. Okay, remember to pop your favorite emoji in the chat when you're ready. Bikanyo, are those tears of joy or tears of sadness? As in physically hurt, or is it the maths that's hurting you? What exactly is hurting you? Is it the math? I'm sorry, my darling. Okay, we still need to know how to do it though. So we can't just assume, yeah, I'm tired, I'm drained, I'm not doing it. Okay, we've got to know how. Right, and I'll give you guys 2 more minutes and then we'll get started. That's okay, Sia. That's all we want. At least you tried. Okay. There's nothing worse than not trying because you definitely then failed. All right, let's have a look at the answer that we're looking for over here. Okay. All of this is going to equal to our distance. We already know that our distance is 15, so I'm just going to plug things in. I'm going to go the square root of, and ma'am's square root is looking real ugly. The square root of, in brackets, x2 is q, so I'm going to have q minus -3 all squared plus, open brackets, y2 is 5 minus -4 all squared, and all of this is equal to 15. All right, and then we're just going to, excuse me, guys, we're just going to then clean it up a little bit. So I'm going to have the square root of, inside the bracket, I'm going to have q plus 3 all squared. I'm just going to remove that. I'll put it in just now. Plus 4 plus 5. 5 plus 4 will give us 9 squared. All of this is equal to 15, the square root of that. Okay, now if I want to remove the square root, I'm just going to square both sides. I'm going to square that side, I'm going to square this side. So I'm then going to get q plus 3 all squared plus 9 squared, which is 81, is equal to 225. Okay, then I'm going to FOIL this part. I'm going to FOIL it out. So I'm going to end up with, I'm just going to continue over here because I'm going to run out of space. Okay. Oh, there's another one. Ah, I see. Okay, so we're going to go q plus 3 times q plus 3 plus 81. And then I'm going to bring this 225 over to the other side. And I'm going to say minus 81, minus 225 is equal to 0. Right, now if I do a little FOIL, I'm going to get q squared plus 3q plus 3q will give me 6q plus 9 plus 81 minus 225 is equal to 0. And then I just need to add like terms. So from here, I'm going to move up here. I'm going to get q squared plus 6q. And then I'm going to get 9 plus 81 will give me 90. So 90 minus 225 would give me how much? 135. Negative 135. Thank you very much, Balissa, is equal to 0. Then I'm going to open up two brackets. Okay, 0. And I want the factors of 135 that will give me 6. So I'm going to get Q and Q. Anybody got numbers for me? I'm going to get positive 15 and negative 9, plus 15 and negative 9, because 15 minus 9 will give us 6. Right, therefore, Q is equal to negative 15, or Q is equal to positive 9. Okay, on a scale of 1 to 10, 10 being confident, 1 being, ma'am, come and rescue me. Where are we sitting? 7.5 is okay, Keratile. We'll take 7.5. Langelish is at a 9. That's good. That is great. Okay, I'm loving the 9s. For those of you who are still feeling a little, okay, lovely, who are still feeling a bit apprehensive, oh, that's a very specific number. Wow. Okay. It does. It does. This step, this one over here is quite confusing. This step over here, there's space to make quite a few mistakes in that one area. Okay. Can I give you one more example to try on your own, guys? I'm going to give you one example to try. Okay. I want you guys to try that one there. Okay. Oh, Sally, I see. Yes, factorization was the one that's going to get you, honestly. It does get quite tricky. It does. All right. Okay, let's try the question over there. So they're telling us over here, the distance between F and G is equal to 9. So we know we're looking for the distance between the two of them is equal to 9. So I'm going to label x1, y1, and I'm going to name this x2 and y2. All right, we've got 5 minutes. Pop your answer to the question in the chat when you're ready. All right. One more minute, peeps. But I'm seeing, I feel like I'm seeing a lot of emojis this time. I think people are feeling a lot more confident. I'm liking it. All right, peeps, that's time. So I'm quickly going to jump into this so that we don't run out of time. Okay, so let's start with the obvious. We're going to take the square root of x2, open bracket x2, which is just x. So I'm going to have x minus -3 whole squared plus y2, which is -4 minus 5 all squared. And all of this is equal to 9. All right, I'm going to go ahead and square this as we go so that I can do that before we even get to the final answer. So over here, x minus -3 will give me x plus 3 all squared plus -9 all squared is equal to 9 squared. So if I multiply out here, I'm going to get x squared plus 3x. Oh, I'm cheating the system here. Sorry, guys. X plus 3 and x plus 3 plus 81. And if I bring this over, this becomes minus 81, which means they cancel each other out, actually, which is so lovely. Right, so I'm going to get x squared plus 6x plus 9. And then 81 minus 81 will cancel. So this then becomes 0. Therefore, my answers are actually just x plus 3 and x plus 3. Therefore, my value for x is equal to 3. How did we do? Oh, -3. Sorry, guys. My answer for x is -3. How did we do, peeps? Did we do okay? 9.5. Okay, we'll take a 9.5. Lovely, guys. Amazing work. Whoop, whoop. Well done. Okay, for those of you at a 9, I hope we see where we got it. Right. Lovely, lovely, lovely work, guys.